StochSS Live is a web app. So you simply go to live.stochss.org and you'll see this web page here. And just looking ahead, yeah, okay. So so if I would invite you now to go to StochSS to live.stochss.org. So if you just type in live.stochss.org, I need to spell it right, live.stochss.org. You're going to be redirected to exactly this page you see here. So you're going to click here to log in. So we've set this up with Google OAuth. So if you have a Google account, and I'm going to use my UNCA account here, this now gives us the home page of StochSS. So we've got our landing page with the ideas that generally you're going to create a new project, browse existing projects, or look for a tutorial. And then over here, this home page will bring you back here. You can list all the projects you have, look at your files directly. This is a link to the Jupyter Hub interface directly. And then, of course, the same tutorial. So I'm going to go ahead here and bring this down. So sort of cover the introduction to StochSS. And now I'd like to go through a few labs and give everyone an idea of what it's like to build up a model and do some simulation using StochSS. So I'm going to create a new project. That project name is going to be SIAM Mini Tutorial, and I'm going to just put live in there. I click this and I get my little project page here, and my new project, of course, doesn't have anything on it quite yet, but I can add models, add a new workflow, etc., etc. I do want to take this moment and say, if you're having trouble with this or you want to do this on your own, I want to show you how easy it is to get set up. So this doesn't work on all computer platforms, but as long as you have Docker installed and you have some of these tools, you can just, let's see, desktop. I'm going to do a git clone, https://github.com/stochss/stochss. So this is going to go to GitHub, and it's going to clone our repository there. Now, the GitHub repository for StochSS is both the software for the user interface as well as the container system itself. So it's going to download this, and it's taking a minute because I'm streaming this over the internet, so my bandwidth is a little bit more limited. So now there's a folder on my desktop called StochSS. I can cd StochSS. See, I have a lot of things here. Now, to run this, I simply type make. Now, make is going to go through a pretty large process here of installing dependencies, etc. But when that's done, it's going to give you a local URL for you to visit, and then you will see the same interface you see here. So I just wanted to make sure that everyone has the ability to do that. This is going to take a minute, so I'm going to go ahead and put it off to the side. Okay, coming back to our project here. So we've got our new project, the SIAM Mini Tutorial. The first thing I'm going to do is make a basic model. So I click Add Model here. I've got New Model, and you see New Spatial Model here. This is in beta. I'll show some of the spatial model stuff tomorrow, but you can also import existing models from other projects you have, or upload the StochSS model here. I, again, forgot an important piece. If I go to github.com, we made a GitHub repository for this, this tutorial. So if you go to this, github.com/stochss/stochss_tutorial, you'll see here that we're going to have a zip file, 2 zip files here. These zip files have all the files that are available here for our tutorial for you to use at any time. And in fact, we have these links. If you just click these links, they will just open inside of StochSS. And This might be a problem because I already have something by that name, but you can say, yeah, if you click that link, it automatically forwards you to StochSS and will download that project as long as you don't have something that's there already. So, yeah, so please, as soon as you get StochSS set up, you can take a look at either of these, or you can follow along and build it from scratch with me. Okay, setup taken care of. Yeah, so now I'm going to create a new model. And the most basic model I can think of that shows off some of the features of StochSS is simply the birth-death model. So I'm going to create a new model. I'm going to call it birth-death. Click here for a second. As soon as I get here, what we've found with our user testing is that when I say modeling, people have a lot of implicit assumptions about what a model is and what it means. So to sort of differentiate between these different kinds of models that people have assumptions out, the first question we want to ask you is, do you assume your variables are going to be represented using continuous or floating point values? Such as, if you have like 1.3 or 1.4, concentrations are typically represented this way. However, in a lot of cases where there's a very small number of agents in the system, whether they be frogs that are dying off or proteins within a certain area of the cell, population models and their intrinsic stochasticity make a much better deal. We also have the ability to do a combination of continuous and discrete values together. Again, I'm going to show some of that off a little bit later. But for this one, I'm going to choose concentration for now. Note that I will change this later on. So I choose concentration, and you note model must have at least one variable. You have to have something that you're keeping track of. So when I talk about birth death, I like to give it something specific that's going on. So I'm going to add a variable, and I'm going to call this variable rabbits, or just rabbit. So I'm going to have some sort of domain, and that the forest, and this is going to start out with some number of rabbits. I'm going to say it's going to start out with 10 rabbits. So this is my initial condition. I say save variable, and then rabbits, initial condition 10, mode is continuous. Next, often we have parameters that tell us the rates of how things change. Typically, this comes in when you use them in reactions. So parameters are not required, but they are very useful. So I know that this is going to be birth and death, so I'm going to have two interactions. So I'm going to probably have two parameters. So I'm going to say the kinetic rate for birth, I'm going to make that 10. And then I'm going to add a second parameter, and then the kinetic rate for the rabbits dying, I'm going to make that 0.1. And we don't necessarily have units here. The units are sort of implicit in your thing. So this might be per month. So 10 rabbits are born per month, and then each rabbit has a rate of dying of 0.1 per month. But the rate is sort of intrinsic here in the units of the parameters. So I'll click Save Parameters. I have these two pieces here. So then I open up the Reactions tab, and you can see Reactions is a process that transforms variables, a set of variables, the reactants, into another set of variables, the products, and usually set at rates set by parameters. And then you might just be aware of the empty set sign means that you may have, nothing goes to something. So in fact, I'm going to show that. So I'm going to click Add Reaction here. Add Reaction gives us a list of commonly used reaction types. So this empty set goes to A, where A is a placeholder for a biochemical species or variable, and this is the creation reaction, and that's what I'm going to select here, because birth is a creation reaction. Maybe I'll make this a little bit bigger. There we go. Okay, so great. So basically what is happening here, and you can kind of see this, maybe I can make this big enough for everyone to see, yeah. That our summary of this reaction is empty set goes to 1 rabbit. And that's going to happen at the rate parameter, kbirth. And I'll add a second one. And that second one is going to be the destruction reaction. So some variable A goes to the empty set. And I'll call this death. Now you don't have to put names in here. We automatically populate that for you, but it's sometimes useful. So in the death reaction, a rabbit is consumed and produces nothing at all. And that's going to happen at rate k death. So that's all I need. A birth-death reaction just has 2 reactions, 2 parameters, 1 species. So we have got the birth reaction. Empty set goes to rabbit at rate k birth. Rabbit goes to empty set at rate k death. Fantastic. Okay. So I'll set this out to a simulation time of 50. And I want to look at it every 0.5 sample time points. And just looking at everything here, that looks great. So we have continuous variables here. So now I'm just going to go to the bottom right here, click simulate, and then click on the preview. And then this bar will go around for a little bit. You'll see that we have this nice plot that allows us to show. We start off with 10, and then we have, short time later, we have 11.76 rabbits. I don't know where the 0.76 comes from, but you know, that's how continuous variables work. And then we just sort of asymptotically approach the steady state of this. So here is exactly what's going on. I'll click save just to show this is saved. I can do things like zoom in on parts of this graph. I can save this as a PNG if I'd like. Download here as an option. And then if I want to hide my preview, I can do that. Perfect. Okay. So while deterministic is interesting, like StochSS is our name, so what I'd like to do is change this variable from concentration mode to population mode. So I'm just going to click this button here, go back to show preview, simulate, preview again. So I'm going to re-simulate this particular piece here. Now you can see that we have what is a very stochastic trajectory, right? Looks kind of like the stock market might do. And as I move my cursor over this, you can see the values are always integer values, right? So we start off at 10, just like before, but then we go to 11, and then 12, and then 13. Every birth reaction happens at a random time, exponentially distributed from the current time, and produces or consumes a single rabbit. So that randomness gives us this intrinsic part here. Now, I can go even a step further and say, well, these are great previews. This has been very helpful. But what if I want to look at a whole bunch of simulations all at once? So that is a whole bunch of simulations all at once. It's called an ensemble simulation. Now, doing an ensemble simulation of a continuous variable is not very interesting. All continuous variable deterministic simulations will always look the same. However, stochastic simulations have a lot of randomness in them. So we can click this, and we're now going to be in a workflow. So a workflow is something that takes a model and then does something more detailed with it. So we automatically give it a name, workflow, ensemble simulation, and then the date and the time. And you can see that it's inside of our project here, and it's inside of this. Okay, so in general, you can just say choose for me, and we will inspect your model to understand what details you have and do the best we can, guessing what kind of simulation algorithm you want to use. However, we can you can choose if you want to. So now we click Start Workflow, and then this runs for a few minutes. And now we have a series of plots that runs of the results. So here, this is the standard deviation range. Just to point out, sorry, I may not have said this out loud. Plot trajectories. Yeah, okay. So this plotted, this ran 100 simulations of the birth-death model that we just did. In those 100 simulations, you can see they always start at 10, And they always, and the mean sort of asymptotes right to about 100. However, we get variation on it. So this is the mean and standard deviation bar of our particular thing. And then I can, edit this plot, save it to the project viewer, download it, download the JSON so I can embed this in a web page if you wanted. I can also look at each of the individual trajectories. So this is a kind of a bigger plot here, but we're looking at each of the rabbits of these 100 different trajectories. And then we have an option to do multiple plots, individual plots at a time. You can also look directly at the standard deviation, which starts at 0 and goes up to about 10-ish. You can also look at the mean. The mean's going to look, increasingly like the deterministic simulation. You can download this data as a comma-separated value file for external processing. No log files, and then we can review our model here if we'd like. So this is a workflow and the easy way to build up a model and get yourself some publication ready plots. So I'm going to click back here, jump back into my project, and you can see now that I've got my birth death model. I've got my workflow I can go back into this and it'll have all those plots back in there. And then if I ever wanted to make a new workflow using this model, I just click here. If I want to add notes, I can do that, saying this is the perfect. All right, so